Welcome to BSc Statistics students. In this lesson, I explain problem 3 of critical path method. In the critical path method, I explain one more problem. You see here, this is another kind of problem. A project consists of the following constraints. These are the constraints. A less than D comma E, B comma D less than F, C less than G, BG is less than H, and FG less than I. What is A, B, C, D, etc.? What are these? Which are activities? A, B, C, D. Here task. It is specified as task, which are having the following times. A is to be completed in 23 days. B is completed in 8 days. It is to be completed in 8 days. Like which total number of days are given for each and every task. In which what is this? What is this kind of relation? A less than D comma E. What is meant by this? What is meant by C less than G? So which means, for example, this is a kind of direct relation. A C less than G. This is called a predecessor activity. This is a successor activity. Predecessor activity, which meant by an activity is to be finished before starting the another activity. Before this G, that is the C is to be finished, completed. The activity C is going to be finished. G should be started after completion of the activity C. This is successor activity. So this is what the relation it is. By using these relations, the constraints, which are called constraints, which means some kind of conditions. We know in the linear programming problem, clearly we have an idea. Constraints meant by some conditions, restrictions. These are the restrictions. A should be finished before starting the two activities D and E. And one more, D and E, the two particular activities are tasks which are to be started after the completion of A. Like that, these are the relations. Now we start the construction of the network diagram. First question. Then when we have to find these, construct the network diagram, find critical path, find minimum project completion of the time, that is project duration. So in which what you have to see when the relations are given like this, then first you have to observe what are the starting activities, what are the ending activities. That which means for which activities there are no predecessors. That is, there is no other activity before that particular activity, which are called starting activities. You consider starting activities. There is no such relation, like no such terminology like that, but you consider it. And then also you find out in these relation, among these relations, also you find out which are the activities having no other activities after that, which means end activities, which are the last activities you consider. Right? You see here, first of all, before A there is no activity, and also you observe here before B there is no other activity, and before C also there is no other activity. After A, B, C we have activities, but before A, B, C we don't have any activities. Similarly, now you observe remaining, there is no activity after I. I is the last activity, like that. F, G, H. H is one activity. After H we don't have any other activity. F, after F we have G, after G we have. And E. After E there is no other activity. So therefore, which are also called independent activities. E, G and E, not G, I'm sorry, E, H and I. These are the end activities. Which are end activities. There is no activity other than after these activities. A, B, C, which are starting activities. Like that, hope you understand how the relations are going to be obtained. And now we can start. So I'm I'm constructing the figure, network diagram. The first question. Network diagram. So I'm constructing the network diagram by using the relations. I take the relation here. I write the relation here. A is less than D comma E. Okay, and after that B comma D is less than F. You start the relations with these, and also write C less than G. Okay. If you consider, there are three activities A, B, and C, which do not have any activities before that, which are called starting activities. Therefore, I'm taking the first node here, first event. I'm taking the first event 1 here, and so that I connect with another activity 2. So I'm considering like this. Basically, if you connect two activities, we will get a particular, if you connect two events, you will get an activity. An activity is formed with the help of the two activities, connecting two activities. I'm considering 1 and 2, and I'm constructing the activity A. Clear? The activity A, which has the time 23 days, that you can observe from the table. A is having 23 days. That is, activity A has, or task A has 23 days. That is the time of completion of that particular activity it was specified. And similarly, you have to construct an activity which is from 1. That is because it is also an independent activity, and I'm constructing the activity B. For example, if it is not suitable, we can erase the figure, and then we can again draw the figure. The activity consists of, that is, it should be finished in 8 days. Okay, and then that is I'm considering third event here. 1, 2, 3 I have connected. I have constructed the activity B. Similarly, C also an independent activity. I'm connecting this particular activity like this. That is the fourth node. I'm taking fourth event, and so that I have connected 1 to 4, and I consider this is an activity C, and the number of days are 20 days. Okay, I have started like this the network diagram, because A, B, and C are independent activities. A, B, and C, which are independent activities. Now you see the relation. A is less than D comma E. Okay. Now you search any relation between D and any other activity, because I have constructed A, I have constructed B. Now you see the next one, B comma D less than F. So therefore, after B, F is going to be started. After B and D, for time being you leave D, and first of all you consider B. After B, if you consider F, let it be, I'm considering F in this manner. I consider one another event here. I give the number later. Okay, so that please keep this particular event as it is. And F I'm considering here. F is having a number of days 18. Okay, we'll see later remaining. And you see, this was not finished. And B and D, which are less than F. Another activity is also there. This is, you see here, this is B, and after that we have F, and before starting F, that is this activity, D also must be finished. B and D, two activities must be finished before F. So therefore, what I'm seeing now, the relation this A is less than D and F. That is, after A, D and E are two activities are going to be started. Before D and E, A should be finished. A is finished here, which means you can consider two activities here and here like this, in the two particular ways. So I'm considering in this way the activity E, but E is we have already discussed E is an AND activity. So therefore, E should be finished at the end for last node, it is to be connected to the last node. So I'm leaving like this. Okay, this is to be connected to the last node. Okay, we'll see. This is you call E, and if you have any that is corrections, we do later. The number of days, time duration is 24 days, right? And one more activity is going to be taken after A. That is after A, I have started here, and after A, we have to start the activity D as well. And luckily, we have another relation between BD and F. That is, before the activity F, B and D should be finished. So B is already finished. If you connect from 2 to 3, let it be the activity D, then obviously B and D are the activities which are finished before F. This is what F. Before that, B is finished, D is also finished. If you connect like this, right? So therefore, it is luckily we have connected for this. The number of days for activity D are 16 your time duration. So that therefore A is less than D. That is before D, A is finished. After A, we have considered D activity and E activity. It was not completed. Okay, we will see at the end. And then C is less than G. So therefore we take another particular activity and we connect to another node. So I'm considering this is one another node. After 4, I have connected this. This is I consider G. So G, I have considered the number of days, that is duration, time duration is 19. Okay, and then now it is required to consider any relation between F and G. Yes, sir. The remaining relations are right here. There are certain relations B comma G is less than H, and F comma G is less than I. There are two other relations. This was finished, this was finished. A is less than D and E. This is A. This is D, this is E, therefore A is less than D and E. B comma D less than F, this is B, this is D less than F, therefore it is also finished. C less than G, this is C, this is G. So therefore obviously after C, G was constructed. Before G, C was finished. The activity C was finished. So therefore this is also satisfied. Now we have to see for remaining two. What are those? B comma G less than H. You see here, now you check. This is B comma G less than H. B and G should be finished before H. So that is what I am forming. After G, H is going to be formed, but H is an independent activity. So therefore I am constructing H at the end event. Okay, this is what I consider H. H is the time duration for H is 4 days. Okay, and then what you have to consider B and G, which is less than H. You see here, this is B and G. After G, H is constructed. H was constructed. Okay, it is good. Then that is, but one more activity is also to be finished before H. What is that? B. B and G less than H. You see here, this is G, this is B. B is here, G is here, and H is here. And don't think that before that is 4 and 3 we have B, and after the 4 we have G. Therefore after G, H is here, therefore B is also finished. No, in the network diagram such kind of relations are not going to be existed. Directly we should have to specify. You see, like this, B and D less than F, which means B is also finished, D is also finished before F, before starting the activity F. So like that, the direct relation is going to be existed. Otherwise, we have to consider dummy activity, which is going to be clearly connected, and it is going to be clearly explained in the network diagram. So therefore, that is there is no relation. These are the independent activities. B is going here, connecting for some other activity F, and G is going, it is constructed here, and therefore B and G are independent activities now. And before the H, the activity H, B and G must be finished. G was finished, no problem. But because B is an independent which is not connected here with G, therefore I am constructing. There is no other way for us to consider to show this. Therefore, we are considering an dummy activity which is going to be connected to G. It is going to be drawn as dotted lines, right? So this is what I am considering dummy activity 1. I am considering dummy activity 1 with the duration 0. We should consider duration 0, right? So this is what, where if necessary only we have to consider dummy activity, otherwise we should not consider. That is the rule of considering dummy activity. You see now B to G, that is B to 3 to some another. I give you the number 5 here. Okay, 3 to 5. If you connect an activity which indicates that it is finished before the activity H. That before H we have dummy activity, and before that we have the activity B. Therefore, B was finished before the activity H. And also G, obviously G was finished. The activity G is already finished before the activity H. Therefore, now this relation is okay, or this relation is constructed. B and G is less than H. Now similarly, F and G less than I. So that is F and G. Where are these activities? This is F, this is G. After that, after G we have H, which so we cannot connect here the activity I. Where you have to connect, construct or connect the activity I is to be connected. We have only one option to consider from F. F2, the I is an end activity. So because it is 5, I am considering this is, I am extending this, and so that I take up to here. That is a simultaneous activity I want to prepare. This is, let us consider it is 6. Okay, after 5, I am considering 6, and so that I finish this, and as well as I consider the activity I here. I consider the activity I here. Is it clear? I consider the activity I is, the time duration is 10 days. Okay, and I am considering this is 7. Now you see, still I have to establish the relation Fg is less than I, F and G. F is obviously less than I. Before I, the activity F was finished. F is finished, that is before starting I. But G was not finished directly. What I have specified that directly these are to be finished clearly. Therefore, F and G, but because F and G are independent activities which have no connection. Therefore, we cannot specify G was finished before I. And to specify this, we have to consider a dummy activity, one particular dummy activity from 5 to 6. Like this, you have to consider in this direction from 5 to, that is the reason why I have taken 5 here and 6 here. Okay, the direction is very important. This is the direction 4 to 5, 5 to 6, right? This is the another dummy activity I have considered D2 with the time 0, time duration 0. Therefore, F and G is finished. After G we have D2 and then I. Therefore, F and G are finished before starting the activity I. Therefore, F comma G is less than I is also finished. So therefore, all relations, you see once again, I show it. A is less than D comma E. That is after A, D and E activities are there. And B comma D less than F. So this is B, this is D is less than F. That is F. After B and D, F is started. The activity F is started. And C less than G, obvious. This is C less than G. After C we have G. And B comma G less than H. Just now I have discussed. this is B and a dummy activity, and this is G, and before that H, that is before H, these two are completed, B and G, and then F comma G less than I. This is F. Before that, after this we have I, and this is G and dummy activity, and after that we have I. So therefore, I is started before I is started after G and F activities. Therefore, these are the relations you have to use, and you have to construct the network diagram. So this is what a difficult task of doing this particular constructing the network diagram with these kind of relations. So hope you understand better. Hope you understand well. Now I calculate forward pass calculations and backward pass calculations directly in the network diagram, right? So I'm considering E1, L1 at the node, at the event E2, L2, at the event E3, L3, at the event 4 I consider E4, L4, at the event E6, so I consider E6 here, L6 here, and E5, E5, L5, and E7 and L7. Is it visible to you, right? Now I start the calculation, forward pass calculation from 1 to 7 nodes. From 1 to 7 events I consider. You know that first of all we have to consider E1 is equal to 0, the starting time, earliest time we have to consider as 0. And next you move to the second event or second node, then E plus D, that is 0 plus 23. Because we have only one connection, one connector. One is connected to 2, therefore 0 plus 23, it is 23. And then you move to the third event. We have two connections, 2 to 3, 1 to 3. And 1 to 3, if you use that, 0 plus 8, 8. And 23 plus 16, it is 39. So the maximum you have to consider 39. And then 4, E4 and E4, only one connector, 0 plus 20, it is 20, right? Next move to the fifth one, E5, it is connected from two particular activities, 4 to 5, 3 to 5. Therefore, E3, 39, 39 plus 0, 39, E4, 20, 20 plus duration 19, 39. So both that maximum is 39, because two activities you have to consider maximum. And then to 6, move to 6, third one, sixth one, sixth one, it is connected from two activities, from two events, it is connected, 3 to 6, 5 to 6. Therefore we see that 3 to 6, 18 plus 39 plus 18, it is 57, right? And one more, it is from 5 to 6, 39 plus 0, 39, the maximum 57. So therefore the value is 57. And then move to the last one, seventh node, seventh event. It is connected from three events. The three activities are formed to 7. 2, 7, 5, 7, 6, 7. These are the 1, 2, 3. 2 to 7, 6 to 7, 5 to 7. Therefore, you have to calculate three values and then take maximum. First one, 23 plus 24. 23 E2 plus duration 24, 47. Okay. Next one, 47. I am writing 47 here. And from 6 to 7, 57 plus 10, 67. Do you understand? 57 E value E6 and D67 is equal to 10. So 67. Coming to the 5, 7, 39 E5 plus 4, 43. So 43, maximum 67. So this is 67. Clear? These are the forward pass calculations from which we have calculated all earliest times, E, the time periods of time values of E. Okay, earliest times we have calculated. And then now coming to the backward pass calculations, by considering the last for the last event, E is equal to L, therefore L7 is equal to 67, E7 is equal to L7. Coming back to 6 first, only one connector, so one connector, therefore subtract L minus D duration, 67 minus 10, it is 57. I am writing here, this is L6, this is E6, this is L6, 57. Then move to the 5, fifth node, fifth event, 5 to 7, 6 to 7, and 5 to 6, 5 to 6, 5 to 7. There are two particular activities which coming back to the 7 to 5, 6 to 5. Now you take minimum 67 minus 4, 63, 57, L6, 57 minus 0, 57, minimum 57. And then coming back to the fourth event, only one, 4 to 5, only one. Therefore, 57 minus 19, it is 38. So, only one. And then coming back to the third event, connections are 3 to 6, 3 to 5. So, therefore, what you have to consider from 5 to coming back to 3, that is L5, 57 minus 0, 57 minus 0, hence it is 57. And then 3 to 6, 57 minus 18, it is 39. So minimum is 39. So L3 is equal to 39. And coming back to 2, second event, it is connected from 2 to 7, 2 to 3. So therefore from 7 to and 3 to, therefore you have to consider minimum. 7 to 67 minus 24, 67 minus 24, 43. I am writing here 43. And then 39 minus 16, 23. The minimum 23. Right? And coming back to the first node, first event. That is, it has 3 connectors, 1 to 2, 1 to 3, 1 to 4. Therefore, calculate 3, 23 minus, this is from 1 to 2. So from the second node to coming back to 1. 23 minus 23, the value is 0. I write here. And 39 minus 8, 31. And last one more, 38. L4, 38 minus 20, 18. Minimum is 0. We should get 0. Remember, we should get 0. So from this particular network diagram, we have calculated also backward pass calculations, forward pass calculations and backward pass calculations. From the backward pass, we have calculated L values from 7th node to first node, 7th event to first event. We have calculated from coming back by taking the minimum values of Lj minus Dij. Li is equal to minimum of Lj minus Dij we have calculated for backward pass calculations. So this is what the procedure of calculating the backward pass and forward pass calculations. And finally, we have to calculate. We have to identify critical path. This is network diagram. The second point is critical path. Critical path. What is the critical path? We have to observe the critical activities for which E is equal to L and it is to be considered. You see E10, L10. This is first event. Second, E2, L2, 23, 23, same. So you connect this. Double line, make a double line. And similarly, E2, L2 are same. E3, L3 are same. So therefore, you connect these two as well. 39, 39. And from this, E3, L3 are same and E6, L6 are also same. Therefore, you connect this. Okay. And from 6 to 7, 57, E6, L6, 57, E7, L7, 57, which are also same. Therefore, you connect this. You say E4, L4, not same. E5, L5, not same, like that. Therefore, this is the critical path. What is the critical path? Critical path is 1 to 2, 2 to 3, 3 to 6, 6 to 7. This is critical path. And what is the duration, time duration, minimum project duration? Minimum project duration. The minimum project duration is nothing but you observe from the last value of E, also L, it is 67, is 67 days. So this is what the calculation of forward pass and backward pass, constructing network diagram, critical path, finding critical path, minimum calculating minimum duration. Hope you understand. Thank you so much.